3 is on subtraction of real numbers. Most easily put, for the rule for subtraction is simply add the opposite. You have rules for addition already, and so just change it to adding the opposite. So we have it right here, add the opposite. So let's go ahead and put it into action. Now, my advantage is I get to use color to really exaggerate this for you, and sometimes it's a little bit harder for you to see this on your own paper. So if you want to rewrite it instead of just changing the symbols. Now, the biggest mistake is changing the first integer symbol. That is not what we said. We said add, so you're going to go to the operation, the opposite. So let me rewrite that. My -4 stays as -4. My minus changed to a plus, making the opposite is going to be a -3. Now the rule is same signs, keep the sign and combine them. So for letter A, we have -7. In letter B, we have 10 minus 11. So I'm going to add the opposite. So again, I keep my 10. I add -11. Go back to your addition rules. Different signs find the difference. So the difference between 11 and 10 is 1. The larger of those is negative. The next one, I have 11 minus 10. Now you've been doing this since you were little. 11 minus 10 is 1. Let's prove it with our new rule. We're going to add the opposite. That's a pretty ugly add. I'm going to undo those. So I'm going to add the opposite, rewriting that so you can see it. 11 plus a -10. Different signs, find the difference. Difference between 11 and 10 is 1. 11 is the larger, so I keep its sign, which is a positive. And oh, they're going to throw some fractions at you here. Doesn't change anything, but this one is slightly different. We had one where the first number was negative. That still stays negative. But we're going to add the opposite. By adding the opposite, now I have plus, that's my adding, and my -1/2 changed to a +1/2. Different signs, -3/2 and a +1/2. I'm combining those. So the difference between 3/2 and 1/2 is going to be 2/2. Take the sign. 2 over 2 equals -1. So my answer there is a -1. All right, moving to the next example. Expressions containing more than one subtraction can also be evaluated by adding the opposite. So to do this, use the left to right rule for order of operations. So we're going to try this expression. Leave the first one alone. Now we're going to add, oops, let's see if I can get that a little bit better. Maybe I went a little too far. I'm going to magnify it on mine. We have 3. We're going to add the opposite. So now I have adding, and my -4 changed to the opposite, which is 4. Add, that's a near miss again. Add the opposite. So now I have adding a -2. And then we have that plus 8. Now we're going to go back to our rules that we were using in the lesson right before this. Let's get our like terms. Those are all the positives. So 3 plus 4 is 7 plus 8 is 15. And we only have one negative, our -2. Different signs. Now we have a simple sentence here. Different signs, find the difference. The difference between 15 and 2 is 13. And 15 is the larger, so our answer is 13. Whoops, sorry about that. So when an expression is written as a sum, the parts that are added are the terms of the expression. For instance, you can write the expression 5 minus x as the sum 5 plus a -x. The terms are 5 and -x. You can use the subtraction rule to find the terms of an expression. Moving on to example 3 then. negative 9 minus 2x. Let's change it to the opposite, negative 9 plus, and the opposite of that, of 2x, would be negative 2x. Let me show you that here. Oops. Negative 9 plus a negative 2x. And now I can go ahead and I can write that as, and that is fine to leave it that way. We have two terms, a negative 9 and we have a negative 2x. Although they're both negatives, they are not like terms. One is with a variable. Now, some people do like to change the order. We can do that because of commutative and have the variable be first. Just make sure you keep the integer sign with that variable. So you could also write this expression as negative 2x plus a negative 9. Then your variable is coming first. So, evaluating a function. We started this a little bit in chapter 1. We're going to continue it. You're going to notice that we have our input and we have our output. Our inputs are the x's, our outputs are the y's, and our function is what's going to change the input to the output. So we're just substituting in. So x equals, is that a negative 2? I kind of circled over it. Yes, it's a negative 2. So what I'm going to do is I'm going to take my function and I'm going to substitute the x in. So for this first one, I would have negative 5 minus a negative 2, as they showed you in the function there. Add the opposite. Now I have negative 5 plus 2. Different signs. Find the difference. We get 3, and it's a negative because the negative 5 was larger. So I went ahead and just copied the solutions. You can see that they're substituting the x in for the function. They're just showing you the substitution right here, and then solving for the y, which is the output. So in real life, we could talk about the stock market. So you're writing a report about the Dow Jones Utility Average, the daily closing averages. Remember, when we do averages, we add up all of the data and then divide by how many pieces of data we had. So the average, the daily closing averages for 1 week are given in the table. Find the change in the closing average since the previous day to complete the table. You're going to notice here we don't have a change because we didn't have a previous day. But to find this total here, we're going to take the 266.13, and it says find the change. So the change is going to be the difference. So I'm going to go ahead and I'm going to find the difference between that and 268.08. Now 268.08 is a larger number, so I'm going to put it on top there. You can definitely use your calculator for this. I'm just finding the difference between the two numbers, and I should come up with 195. Now we're moving from here to here. This is the larger number, so the 195 is going to be positive. Now I'm going to, for the next one, I'm going to find the difference between the February 10th and the February 11th. Again, I'm going to go with my larger number, 268, if I'm going to do this manually and not on a calculator. And I'm going to find the difference. So on the 11th, I had 267.11. The change is the difference between those. And the difference this time is going to be 97 cents. Now I'm going to look and see which one is, am I going positively or negatively? I was at 268 and I went down to 267. So that means that that was a negative change. From the 11th, I went back up. That's going to be a positive change. I'm going to find the difference though. And from 269.37 to 268, I went down a little bit. I dropped a little bit. And so that would be a negative. I went down. So each of those, we're going to always find the difference and then label it with a positive or a negative. My answer for the February 12th one is going to be $2.26. These are in your book as well. And my difference for the next one, again, is a negative. On February 13th, of course, it's the 13th, is going to be a negative, and then the difference between them is $1.35. And that is the end. Example 6 just tells you how to use your calculator. If you want to check that out in your book, it will show you how to use the keystrokes to use the positive and the negatives. And you are able to use those during a test to do any of the calculation between them. But remember, your calculator does not have a brain, so you should still be able to apply the positive and negative rules, knowing if you're making a profit or if it's a loss, using the signs and using the rules for addition and subtraction.